Welcome. In this video, we will explore how mobile subscribers are authenticated in 3G mobile systems. If you have not yet watched the previous video on subscriber authentication in 2G mobile systems, I highly recommend checking it out first, as 3G builds upon those foundational concepts. Mobile subscribers are uniquely identified within a network by International Mobile Subscriber Identity. The IMSI is composed of three parts: the mobile country code, which identifies the country; the mobile network code MNC, which specifies the mobile network within that country; and the mobile subscriber identification number MSIN, which uniquely identifies the subscriber within the network. IMSI plays a crucial role in the subscriber authentication process. The term mobile station typically refers to the combination of mobile equipment and the UMTS subscriber identity module USIM. USIM is a removable smart card that securely stores the subscriber's identity and cryptographic credentials. It contains International Mobile Subscriber Identity, which uniquely identifies the subscriber within the mobile network, and secret key, a 128-bit key used to authenticate the subscriber, and F1 and F2 are message authentication functions for network and user authentication. F3, F4 and F5 are key generating functions to derive the ciphering key, integrity key and anonymity keys. When a mobile device is powered on with a USIM inserted, it initiates access to the network by sending its identity, which is International Mobile Subscriber Identity IMSI, along with context information such as the reason for connection, which is updating the location as part of the attached request. In a typical deployment, multiple node Bs are managed by a radio network controller RNC. To ensure wide radio coverage, networks comprise several node Bs and radio network controllers. Together, they form the radio access network, more precisely referred to as UTRAN in 3G systems. Based on the attached type, the UTRAN determines the appropriate core network node to route the request. If the attached type is IMSI attached, the request is routed to the MSI VLR. If the attached type is GPRS attached or combined attached, the request is routed to the SGSN. For this discussion, let us consider attached type is IMSI attached, where the request is routed to the MSI VLR. While many nodes exist within the core network, in this video, we will concentrate on those involved in the subscriber authentication process. Upon receiving the attached request, the MSI VLR initiates a send authentication info request to the home location register and authentication center, including the subscriber's IMSI. As soon as send authentication info request is received with the IMSI details, HLR AUC generates 128-bit random number RAN, generates 48-bit sequence number SQ1, identifies 128-bit secret key based on IMSI, and identifies 16-bit authentication management field AMF. Authentication Center uses several message authentication and key generating functions to derive the various keys, starting with random number, secret key, sequence number, and authentication management field details provided as input to message authentication function F1 to produce message authentication code, which will be used for network authentication. Then random number and secret key details are supplied as inputs to message authentication function F2, which produces signed response which will be used to authenticate the mobile station. Further, random number and secret keys are provided as input to key generating function F3 to produce ciphering key, which is used to encrypt the communication. Then the same random number and secret keys are provided as input to key generating function F4 to produce integrity key for integrity protection. Then the same random number and secret keys are provided as input to key generating function F5 to produce anonymity key to conceal the information. Finally, authentication token AUTN is generated by using sequence number, anonymity key, authentication management field, and message authentication code. Random number RAN, signed response SRES, ciphering key CK, integrity key IK, along with authentication token AUTN forms the authentication vectors in the 3G mobile systems. Once authentication vectors are produced either on demand or retrieved already generated ones, HLR/AUC responds to MSC VLR by providing the authentication vectors in response to send authentication info request. Then MSC VLR initiates authentication request towards mobile station via radio network controller and node B by providing random number and authentication token. Once random number and authentication token details are retrieved by the mobile station or received by the mobile station, it starts computing message authentication code MAC by using authentication token and random number and secret key. If the message authentication code received from the network is same as the one which is computed by the mobile station, then network authentication becomes successful. If they do not match, then network authentication gets failed. Post successful network authentication, mobile station computes the signed response using random number received from the network and secret key available in USIM and responds back to the MSC VLR via node B and radio network controller RNC. Once MSC VLR receives signed response in authentication response message, it verifies whether the received signed response from the mobile station is same as the one it has received from the HLR AUC. If so, mobile station authentication becomes successful and continue with update location process. If not, mobile subscriber authentication is failed and will not be able to connect to the network. As we have seen so far, 3G mobile system implements what is called mutual authentication mechanism, wherein mobile station authenticates the network and network authenticates the mobile station. Mobile station uses authentication token to authenticate the network, while network uses signed response to authenticate the mobile station. This added security mechanism in 3G mobile system helps in avoiding mobile stations connecting to false or rogue node Bs and revealing their identities such as IMSI. Stay tuned as we continue to delve into subscribers authentication in mobile networks, especially in 4th generation mobile system 4G in the upcoming video. Thank you for watching. Hope you find this information engaging and useful. Please like and share with others who might benefit from this insightful information. If not yet subscribed, please do subscribe. Thank you.